In this video, I would like to talk to you about Azure Site Recovery for both Hyper-V and non-Hyper-V scenarios. So we're mainly going to talk about Azure Site Recovery, what solution it is, and what you can use it for. And then zooming in a little bit more on the technical deployment side, where there's a small difference between using it for Hyper-V based scenarios or non-Hyper-V scenarios. Let me start with explaining what Azure Site Recovery is. Azure Site Recovery is a replication-based recovery, and if you want, also a virtual machine migration tool, allowing a replication between on-premises data centers or between an on-prem data center and Azure, where by default it's not just replicating data, it's also performing replication of the virtual machines. And then very interesting, the source environment can be Hyper-V in combination with System Center Virtual Machine Manager, or it can also replicate from a VMware-based source from physical machines, supporting Amazon AWS virtual machines, as well as Azure Service Manager VMs, the classic Azure, basically migrating VM workloads to Azure Resource Manager. The deployment itself is pretty much identical to what I explained in the previous steps around backup, so it's again wizard-based like scenario from the portal or integrating with PowerShell. It starts with creating an Azure Site Recovery Vault, as well as creating the automatically generated registration key. You download the Azure Site Recovery Provider, which is basically an agent. You run it on your Hyper-V virtual machine infrastructure host machine or on virtual machine manager machines. At the same time, on the Azure side, you create a storage account. Since you're replicating to virtual machines, obviously you also need to provide a storage account as well as a virtual network for the Azure Site Recovery Vault. And then in the next step, you're going to configure the protection for virtual machines, where the interesting part is, compared to other solutions that are doing similar activities, it allows you to individually select your virtual machines. So it doesn't mean that you have to select all your virtual machines at once, or it requires you to select all your VMs from one virtual machine manager cloud. It's basically up to you to decide which VMs you want to take into protection and which not. In the next step, you're going to configure your recovery plan, where a recovery plan is basically a detailed step-by-step scenario, like start up virtual machine 1, on top of that execute a specific PowerShell script, and then start up virtual machine 2, and so on and so on. This also has an interesting fact where you can perform a test failover plan without touching any production related virtual machines, and then in the last step executing a full disaster recovery simulation, which can be a planned or unplanned failover process. And I'll talk about that more in my demo. For now, I want to share some more details besides the technical side. Quite interesting and important, all application traffic is encrypted when it's passed on to Azure by using HTTPS and using port 443 by default. The Hyper-V hosts themselves must have a direct or integrated with a local proxy server is also supported, internet connection, and having Azure Site Recovery agent installed. Now watch out, there's a different agent, a different provider for Hyper-V standalone and for Hyper-V in case of a virtual machine manager. So it's up to you to select the correct one during the initial Site Recovery Vault configuration from the Azure portal. Another important side remark is that the virtual machine operating system must be supported in Azure. So imagine that you're running a Windows Server 2000 virtual machine on premises. This operating system is obviously not supported in Azure, which means that it's also not supported in Azure Site Recovery. Another thing is that the virtual machine configuration must also be supported in Azure. So an easy example here is, for example, a virtual machine having more than 16 disks, which for the time being is not supported in Azure. And then a couple of words about the test failover, planned failover, and unplanned failover, where test failover means that it's creating an identical copy, like a full snapshot of your already synchronized replicated virtual machine, and it's executing a failover using this copy VM. The real advantage of this scenario is that it's not touching your production replicated virtual machine. A planned failover and unplanned failover basically means the same, where there's a slight small difference. A planned failover means that both environments are in sync and they can actually talk to each other, where an unplanned failover should be used as a true disaster recovery scenario, where you're not even having any communication anymore between Azure and the on-prem environment. So this was a quick intro on Azure Site Recovery for Hyper-V based infrastructure. I could almost repeat myself when I'm talking about non-Hyper-V based workloads like VMware, AWS, Amazon, running physical machines, where the main difference, and basically the only difference, is in step 2 of the configuration, where instead of just downloading an agent, the ASR provider, in the non-Hyper-V based scenario, you have to download and install what's called an additional site recovery configuration and processing server, which needs to be installed on a dedicated Windows Server 2012 R2. This machine can be a virtual machine, and it will act as some kind of gateway, replicating all changes from the on-prem environment directly into the Azure environment. So again, the main difference is, instead of just installing the agent or ASR provider as it's called, in a non-Hyper-V scenario, you need to install this additional server, and then installing and running the ASR configuration processing server, registering this machine by using the ASR encryption and registration key, but overall the concept and scenario remains the same, which means creating a storage account for ASR, creating virtual network for ASR, defining your protection, creating a protection plan, executing the recovery plan configuration, and then running a test failover. And then in the end, finally moving to a production site recovery state by executing an unplanned or planned failover. So again, ASR, Azure Site Recovery, in my opinion, a really interesting solution, and it basically supports about any workload. So let me share a couple of words around the configuration itself, where again, replication of the traffic is using HTTPS port 443, and the source environment must have a direct or proxy connected internet connection, and there must be a direct network communication between the ASR configuration processing server and the virtual machine or physical server source. Also take into account that the ASR configuration server acts as a caching and conversion server. So if, for example, your source environment is running VMware ESX machines, running VMDK files, then out of the ASR configuration and processing server, it will push out the replication data to Azure, and at the same time creating Azure supported VHD format disks, and then continuing the replication of the data. Failover and failback obviously is also supported even when the source infrastructure is not available anymore. So think of a true disaster where you're using your data center, or maybe less severe, losing one of your physical hosts. Then you redeploy the VMware hosts, you install the ASR configuration processing server, and then performing a failback out of ASR from the portal, or again by using PowerShell, it will create an on-prem virtual machine from scratch. Pretty cool solution. Now, one thing I have to really stress here is that in case of a physical server failback, it will always create a VMware-based image, since ASR can't cover all physical aspects of a physical machine. Now, so far I've been talking about Azure Site Recovery in a disaster recovery scenario. Now, interesting enough, ASR is not just about disaster recovery, but you can also use it as a migration tool. Since ASR performs a full machine replication, it's perfect for migrations. The main difference between using ASR for using disaster recovery and using it for the migration is one small step. Once the replication is complete, you're going to complete it, commit the changes, and then it's basically disconnecting from the source environment, which means you replicated the full virtual machine state, and once the full virtual machine state is in a full sync, you complete the site recovery process, committing the replication, and your VM will become a production-ready virtual machine in Azure, and obviously you're not using the true disaster recovery aspect anymore. Out of ASR, it will shut down your on-prem environment, starting up your virtual machine in Azure, and this one will be production ready. So it's an easy way for migrating IaaS workloads, also known as lift and shift migration, from an on-prem environment to Azure, or from the classic Azure, or if you want from AWS, from physical machines, it doesn't really matter. It's a virtual machine lift and shift migration. And then obviously the general site recovery guidelines that I already walked you through, like the operating system needs to be supported, the virtual machine configuration needs to be supported, are still valid. So quite a lot of explanation. I think it's a good time to walk you through another demo again. So in this first demo, I'm going to show you how Azure Site Recovery is working. And obviously I'll start with creating a new Azure Site Recovery vault. For now I'm using the portal and then from the marketplace searching for recovery. In the list of suggestions I find backup and site recovery. I confirm the creation in Azure Resource Manager. I need to provide a unique name, linking it to a resource group, and selecting my location, which is my Azure data center. Then when I go back to my site recovery vault, I now have to go through a 3-step scenario. Step 1, preparing the infrastructure. Step 2, replicating the VMs. And step 3, managing my recovery plans. If from here I go to prepare infrastructure, and it's showing me 5 individual steps to walk through, mainly making a couple of selections. So in the first step, I'm going to define Azure, and my source machines are virtualized using Hyper-V, and I'm not using Virtual Machine Manager. Now again, these options are important, making sure you download the correct agent, or as we call them, Azure Site Recovery Provider. Other options, as you can see, is using VMware-based infrastructure or using a non-virtualized, which means physical machines, or fooling the system a little bit if your VMs are running in Amazon AWS or Azure Classic. Then in the second step, if you have to install your agents, so you select Add Hyper-V Server, and then in step 3, you download the installer, Azure Site Recovery Agent, as well as the Recovery Vault registration key. You download them on your Hyper-V host, and in case of System Center Virtual Machine Manager, you don't install it on the Hyper-V host, but you install them on the VMM management servers. And then confirming. In the next step, you can select storage accounts, network accounts, that's all fine, and then defining the replication settings. In the replication settings, you define how the replication happens from on-prem to Azure. You need to provide a name for the policy, providing the source and target environment, and then also defining the copy frequency, which by default is 15 minutes, can be altered to 5 minutes and even up to 30 seconds. Defining how many recovery points you want to create, and if needed, if you want to take an application consistent snapshot, that's the last parameter here, to define, and then you can specify when the replication itself needs to happen. So whenever I need to select a virtual machine, I link it to this replication policy. It will immediately start replicating, but you can also specify to run the replication after business hours. And then I confirm that I ran the capacity planner, which basically is an Excel file allowing you to make some calculations based on source environment, and then the Excel file calculations will give you an estimate how long the replication will take before it's complete. So this is all pre-configuration. Then in main step 2, replicate application, I'm going to select my source VM, specifying the target, which in this case is Azure, where I need to provide a resource group, selecting the storage account and network I want to use. This could be an isolated network or it could be a shared one if I'm already using it for running other virtual machines in Azure. And then in step 3, it will talk to my Hyper-V host, recognizing my local running VMs on the host. Again, these can be Windows machines, can be Linux machines, where I have to specify if it's running a Windows or Linux operating system and if the machine has multiple disks. Where I also have to specify which of the disks is the operating system disk and the other ones are the data disks. Then confirming this configuration, and it will finish step 5. And then again, for this specific machine, it will start replicating immediately to Azure. Now obviously, since replication takes some time, I already did this pre-configuration for this one, and I'll show you. Don't worry too much, it's showing you some error messages here. I just want to show you that the monitoring is also integrated in the portal. So as you can see here, I have a specific virtual machine, which here is in a protected state, which means it's fully replicated. Since it's a protected state, I can execute a planned, unplanned, or test failover. If I'm executing my planned failover in this specific scenario, it will replicate from Hyper-V to Azure. Now, since the machine is already in sync, it will only take a couple of minutes before the virtual machine is fully synchronized, then starting up the virtual machine in Azure, shutting down the virtual machine in my on-prem environment, and after only a couple of minutes before the virtual machine is up and running in Azure, I can connect to it and my failover is completed. If I go to my notification area here, you can basically follow each and every step of the failover process, like some prerequisite checks, shutting down the VM, preparing the failover, starting the failover, and then last step, starting the replica VM. Again, it's only taking a couple of minutes. At the same time, let me quickly show you how it's working for non-Hyper-V workloads, where the initial concept is the same. You create a recovery vault, you go to site recovery settings, and then again preparing the infrastructure, where this time you're going to specify it's a non-virtualized or if it's using VMware. Step 2 is mainly the same, where instead of just adding hosts, you need to add your configuration server. The configuration server installation is again downloading the ASR unified setup, including the vault registration key, and running this on your local machine. Now again, for this demo, I already did the pre-configuration of the configuration machine. So if I jump back to my machine, the initial site recovery unified setup is pretty easy to go through. And once the configuration is done, you can add local machine accounts. Local machine accounts meaning local accounts that can be local admin users on the virtual machines, can be local admin user, or in case of Linux, you have to provide a root account, including the password, which allows the configuration server to connect to all VMs or even physical servers in the source environment. Then configuring the registration vault key, which you can download from the Azure environment. You select the file, register, and then in the configuration details, you can get a view on the data transfer port, which is not 443 because we're using an additional server. The default port is 99443, but to emphasize, it's still a secured encrypted communication between your on-prem machine and Azure. And then once this setup is done, the server will be recognized on the Azure side, and everything from here is about the same as I already showed you in a Hyper-V scenario. Where again, one small difference that I want to point out is this next step. I select my source, my Azure Classic configuration server in this scenario. In step 3 here, as you remember from the previous demo when I was running a Hyper-V based environment, it's automatically recognizing my source environment VMs, where in case of a non-Hyper-V scenario, I manually have to add my machines. So in here, I'm using classic VM2 with specific IP address, and it's a Windows machine. So now it will gather or talk to my physical machine. So from the Azure Site Recovery Vault test communication, it will talk to the configuration server, and then the configuration server will connect to the IP address of the client that I specified, trying to connect using one of the specified admin accounts. And once the communication is fine, I can confirm it here. It will start replicating the VM, and after the replication is done, it's ready for recovery. Now let me quickly come back to my planned failover to see if it's actually successfully done. It's only been running for a few minutes here, but in the end what it does is creating my recovery resource group in which I have my 3 failover VMs, and from here I can see that my VM is running. I can connect to it if my network security group obviously allows RDP connection, and then from the site recovery settings I could also execute a failback, which basically again means it's another failover in the other direction. So this completes my demo on Azure Site Recovery from both Hyper-V source environments and a non-Hyper-V workload.